Hey guys, and welcome back to another video on the channel. In today's video is pretty much a part 2 to our first video on introduction to the chain rule. So we're just going to be continuing questions from that video pretty much. So pretty much differentiate the following with respect to x. So let's just start with question A pretty much. So we have y equals 2x minus 1 to the power of 7. So first of all we need to identify our inside function. So our inside function is here. So what we're going to do is let that equal u. So let u equal 2x minus 1. So if I substitute u into here, that means y is going to be u to the power of 7. Now we're just going to write the chain rule. So dy dx is equal to du dx times by dy du. So the differential of our inside function, which is this guy here, multiplied by the differential of our outside function, which is here. So du dx, if I differentiate this with respect to x, all I'm going to have is 2. And here, if I differentiate with respect to u, I'm going to have dy du is going to be 7u to the power of 6. So that means dy dx is going to be 2 times by 7. And now we substitute that back in our u, which is 2x minus 1 all to the power of 6. So that means dy dx is 14 2x minus 1 to the power of 6. And that's how you do question A. So that one's done. Let's move on to the next question. I'm just going to move this chain rule into the corner here so I don't have to write it again. So, second one, B, we have y equals 5x plus 2 to the power of 12. Identify our inside function, which is 5x plus 2. So let that equal u. So let u equal 5x plus 2. That means y is equal to u to the power of 12. So I substituted u there. So differentiating this side, I'm going to have du dx equals 5. Differentiating this side, so dy du is going to be 12u to the power of 11. So I bring that power down the front and subtract the power by 1. So using the power rule with all these. So that means dy dx is going to be 5 times by 12. And now I substitute the u back in. So it's going to be 5x plus 2 to the power of 11. So that means dy dx is going to be 60 5x plus 2 to the power of 11. And that's how you do question B. So you can see a lot of them is the same stuff pretty much, but I'm just going to go through every single example so you have working for all of them. But yeah, just pretty much identify the inside function and differentiate pretty much. If you have any questions at all, try and leave something in the comments and I'll try my best to answer them. So I'll write about this. C, we have same example pretty much. Y is equal to 1 minus x to the power of 4. Identify inside function, which is this guy here. So let u equal that. 1 minus x. Y equals u to the power of 4. So using the power rule, like we've done the previous ones, du dx is going to be negative 1 because 1 turns to 0 and negative x turns into 1 because that 1 comes down the front. So if you're differentiating just x, what we have is the 1 times by 1, x to the 1 minus 1. So hence we get 1 times x to the 0, which is 1. So that's why that's negative 1. And this one here, dy du, is going to be 4u to the power of 3. So that means dy dx is going to be negative 1 times by 4, substituting the u back in there. So it's going to be 1 minus x to the power of 3. So dy dx is negative 4, 1 minus x to the power of 3. And that's it. So same pretty much deal with all these ones here, but I'll just go through all of them and show you how to do it. So that one's done. So D, y equals x minus 1 to the power of 30. Identify inside function, which is here. So let u equal that. And then that means y is equal to u to the power of 30. So that means du dx is going to be 1. dy du is 30 u to the 29. So that means dy dx is going to be 1 times by 30 brackets, insert our u, the power of 29. So that means dy dx is 30 x minus 1 to the power of 29. And that's it, very much. Alright, so that one's done. Get rid of this now. So question E, we have y equals x to the power of 5 minus x to the power of 10 all to the power of 20. Identify inside function, so pretty much this guy here. So go let u equal x to the 5 minus x to the 10. So that means y is u to the power of 20. Differentiate this side, so you're going to have du dx. Move that 5 down the front, so you have 5, and then subtract the power by 1 to the power of 4. Move that 10 down the front, so you have minus 10x to the power of 9. Then you're going to differentiate this side here, so dy du is 20 u to the 19. So that means dy dx is going to be 5x to the power of 4 minus 10x to the power of 9 multiplied by 20. Let's get rid of that bracket actually, and let's move all this stuff a bit closer. There's going to be 20, insert the u, so x to the 5 minus x to the 10 to the power of 19. So all you can do is just leave it like that pretty much, because there's nothing there you can really simplify, and that's how you do that one there. So let's just do F, which is our final one for this slide, and then we'll move on to the next questions. So a lot of it is very repetitive stuff, but the only way you can really get better is just by practicing it, identifying our inside functions. Now these ones are pretty obvious. It's pretty much what's in the brackets here, but not all the time will it be obvious. So for example, you might get sine curves or log curves where it won't be as obvious, but getting these fundamentals down is probably the most important part. Okay. Power 4. Okay, so identify inside function, and just practicing your general power rule as well helps a lot. So let u equal x minus x cubed minus x to the 5, and y equals u to the power of 4. So differentiate this side, du dx equals 1 minus 3x squared minus 5x to the power of 4. dy du equals 4u to the power of 3. So that means dy dx is going to be, let's move all this stuff here. Let's actually write down here actually. dy dx is going to be this term, 1 minus 3x squared minus 5x to the power of 4 times by 4, and then u, x minus x cubed minus x to the 5 to the power of 3. And that's that one done, okay? If you have any questions about these ones here, just try and leave something in the comments and I'll try my best to answer them, okay? Let's move on to the next part. Okay, so A, find the derivative of that. Find the gradient of the curve at the point x equals 1 and y equals 81. Okay, so first of all, differentiate this. So we have y equals 2x to the power of 3 plus 1 to the power of 4. Identify inside function, and we can see it's a chain rule because it's a function inside a function. So the chain rule means differential of the inside, so du dx, times differential of the outside, which is dy du. Okay, so this is our inside function here, so highlight that and let that equal u. Let u equal 2x to the 3 plus 1, which implies y equals u to the power of 4. Okay, so now we've got to find each of these individual parts. So du dx is going to be 6x squared. dy du is going to be 4u to the 3. So that means dy dx is going to be 6x squared times by 4 brackets 2x cubed plus 1 to the power of 3. Okay, so exactly the same question as we just done before. Now B is pretty much an extension of that. So find the gradient at the curve of, which is our given curve there, at the point 1 and 81. Now it doesn't matter what the y is because that's not in our differential here. It only matters what x value it is. So if you want to find the gradient at that point, all you got to do is sub in when x is equal to 1 pretty much. So in other words, we're going to have dy dx when x equals 1. So substitute wherever there's an x, substitute pretty much with a 1. So what we're going to have is pretty much, alright, 6 times 1 squared times by 4, brackets 2 times by 1 cubed plus 1 all cubed. So dy dx x equals 1. The front bit's going to be 24 times by 4 cubed, 16 times 16, I'm not fully sure what that is actually off the top of my head, I'll use a calculator, 256, okay, so 256 is in here, because this will be 2, actually, where did I get the 4 from? Sorry, I made a mistake in there. That's going to be 3 squared, which is 27, 3 to the power 3, which is 27, sorry, times by 27, so 24 times by 27 gives you 684, okay? So pretty much when you have something like this, it's asking for the gradient at a specific point. So what the differential gives us, it's an equation that gives you the gradient at any specific point. So for example, we've got this random curve here. We can put in an x value and it gives us a corresponding y value. So if I put in like x equals 1, it gives me a y value over here. Let's say it was like 3. But what this differential does is when you put in an x value, it gives you that steepness at that particular point there. So that's why we pretty much work these out. So whenever you're asked a question, okay, if you're given such and such as an equation, what is the gradient at a particular point? All you need is step 1, differentiate it, and step 2, just sub in that x value because the y value doesn't matter unless it's implicit. But that won't be discussed pretty much in math methods. Let's move on to the next question. If you had any questions about this one here, try and leave something in the comments and I'll try my best to answer them. Okay. So the diagram is a sketch of the function f of x, 1 over 2x plus 3. Find the gradient at the curve. Find the gradient of the curve at the point x equals 0 and y equals a third. Find the coordinates of the point on the curve which the gradient is that. Okay, so A is exactly the same as question B here. So step 1, we've got to differentiate this. Now I don't like how this looks, so I'm going to change how it looks. So what we have is y is equal to 1 over 2x plus 3. But we can rewrite this using a negative exponent. Sorry. So you have 2x plus 3 to the power of negative 1 is the same as that. So all I did was put that up there and change it to a negative exponent. And now we can see this is a chain rule. So what we got to do is write our chain rule. So dy dx is du dx, the differential of the inside, times by dy du, which is the differential of the outside. So u is 2x plus 3, y is u to the negative 1. So we're going to have du dx is 2, and dy du equals negative 1 u to the negative 2. Okay? So dy dx is going to be 2 times by negative 1, bracket, substitute our u in, so 2x plus 3 to the negative 2. Now we can rub this out because we don't need this anymore. And now we can put that up there. So we'll have dy dx equals negative 2 all over 2x plus 3 all squared. Okay? And that is the equation for our differential. So we'll move that up there. And we'll get rid of this all together because we don't need that anymore. So this is what we've got for our differential, and now it asks find the gradient at the curve 1, 0. So if we're looking at it here, we can see the gradient is going this way. So we're expecting a negative number, okay, for our gradient. So what we've got to do is go dy dx at x is equal to 0. So we're going to have negative 2 on 2 times by 0 plus 3 all squared. So what we're going to get is negative 2 on 3 squared, so negative 2 on 9 is our gradient. Now, that is exactly the same as our answer for B, because if we look at B, the question is find the coordinates of the points on the curve at which the gradient is negative 2 over 9. Well, we found one, but notice their language. coordinates. The other one is here, because we have two parallel lines there. So if if I highlight that one a bit more obvious, this line here, because we're going to have two parallel lines. They're both going to be -2 on 9. So there is the other curve here. So what we're going to do now is, alright, we've got to make this equal to our dy dx. Now we can see we've got a quadratic term here, so we're going to get two numbers. So our two solutions are going to be 1 when x is 0, and this one here when x is such and such, but it'll be a negative number. So what I mean is, if we rub all this out now, set this number equal to dy dx. So move this guy up here, and if I do this, I'm going to get two x numbers. So I'll get -2 on 9 times by 2x plus 3 all squared equals -2. Okay, so all I did was multiply both sides by 2x plus 3 all squared, and that cancels out, and that moved it up there to here pretty much. Okay, alright, let's rub this out. And let's try and get as much room as we can. Okay, so what we will ideally want to do is try and get x by itself. We can see we're going to get a quadratic term, so why not we expand this bracket? So we have 2x plus 3 times by 2x plus 3, because that is what 2x plus 3 all squared means. So now what we're going to do is multiply by this to this, and this to this. So 2x times 2x is going to be 4x squared. 2x times 3 is going to be positive 6x. 3 times 2x is going to be positive 6x. And then 3 times 3 is positive 9. So we're going to have 4x squared plus 12x plus 9. And that's going to be this guy here. So we can put that in there if we wanted to. So I'll rub this out now. And we have bracket 4x squared plus 12x plus 9 equals that. If I divide both sides by -2, I can see they cancel out. So all I'm going to have is pretty much, alright, I have 1 on 9 equals 4x squared plus 12x plus 9 equals 1. Okay, multiply both sides by 9. We can see it cancels out there. So in other words, we have 4x squared plus 12x plus 9 is equal to pretty much 9. I can see I've got 9 on both sides, so if I minus 9, those cancel out. So in other words, I get this following expression where I have 4x squared plus 12x equals 0. I can take out a factor of 4x, so I get x plus 3 equals 0. So now I've got this scenario here. So if I rub this out and move this up here. So what this scenario tells me is the product of these two things equals 0. So that means this has to be 0 or this has to be 0. Now notice when x equals 0, that's actually one of our solutions here when the gradient is -2 on 9. We're looking for this other one here. So whatever that x value is. So when this equals 0, so x plus 3 equals 0. So if I solve that for x, I get x is equal to -3. Now, we're not done. They said coordinates, not x values. An x value is not a coordinate. It is just a singular number on the horizontal line. We need a vertical position as well. So, once we have this number, alright, we have a gradient. So dy dx is -2 on 9 at x equals 0 and -3. Great. We know what that coordinate is because they gave it to us in the question, but we still need the coordinate when it's -3. So, take our original function because we have f of x. This is the same as y. Doesn't matter how you write it. You can write it in different notations. All we're going to do is substitute this in here pretty much. So we'll get, alright, f of -3 gives me 1 on 2 times by -3 plus 3. So what we're going to get is 1 on minus 6 plus 3 gives you -1 on 3. Okay, so our coordinate here is -3 minus a third. And that's it. And now you've answered the question, okay? Hopefully that one made a bit of sense. If you got a bit lost, try and leave something in the comments and I'll try my best to explain it a bit better. But yeah, that's how you would answer that question there. Let's move on to the final question of the video. Okay, so consider the family of functions with the rules of this form here. So the reason why they said family of functions is because, well, for starters, we have a here, where a is probably just some number, pretty much, that you can plug in. So if you plug in different values of a, you get different functions. So that's why they've addressed it as a family of functions, because it's not one specific one. Okay, so a is a non-zero real number. So pretty much a is a number that isn't zero, because if it was zero, that whole function wouldn't exist. So find f dash in terms of x and a, and yep, we'll pretty much go from there. So we have pretty much a function side of function. So I'm just going to rewrite it like this. So we have y equals a of 4 minus x squared all squared. Now, a is a number. We don't need to differentiate that. So all we're going to do is differentiate this term here. Now we can see that's a chain rule. Inside function is here. So I'll just write the chain rule down here. So dy dx equals du dx times by dy du. So let u equal 4 minus x squared. So that means y is equal to a u squared, okay? Because a is a number. So du dx is going to be minus 2x. dy du is going to be 2au. So all I did was bring that 2 down the front. I left the a because it's a number, so you don't need to differentiate with respect to that. Just treat it as a constant, like if it was 6 or 5 or whatever it is, okay? So that means dy dx is going to be minus 2x times by 2a. Now I can put the u back in here, sorry. So it's going to be 4 minus x squared. So we're going to have, see what we can simplify. So minus 2 times by 2 is going to be minus 4xa brackets 4 minus x squared is dy dx. In other words, dy dx is the same as f dash. I just changed the notation pretty much because I could. Let's rub this out because I assume we'll need more working for the rest of the video. Let's rub that out. Move this guy. I left one of the brackets down there. Right, so that is the answer to A. Find in terms of A, f dash, so in other words dy dx when x is equal to 1. So we're going to have minus 4 times by 1 times A, and then we have 4 minus 1 all squared. So we're going to have pretty much dy dx when x is equal to 1. We're going to have minus 4a, and then we'll have 4 minus, so I actually have 3 in there, so we'll have minus 12a. Okay? So the gradient at x is equal to 1 for this particular function or family of functions is going to be minus 12 times by whatever the value of a is. So that is my answer for question BI. So I'll put that there. And we'll get rid of that. The x coordinates of the stationary points on this curve. Okay, so stationary points is when dy dx equals 0. So set this equation to 0, so you get 0 equals minus 4x of a, and then 4 minus x squared. Okay, so looking at this, we've got a product of two things. If this is 0, that means either this needs to be 0 or this needs to be 0. So that means we have a stationary point straight away with this guy here when x is equal to 0. Okay? Because if I made that equal to 0, I had 0 equals minus 4ax, and I've got 0 equals 4 minus x squared. Okay? So that implies x is 0, and this implies, if I move the 4 over, I'll get minus 4. Divide by negative 1. So I'll have x is plus or minus 2. Okay, so we have 3 stationary points when x is 0, 2, or minus 2. Okay, and all that's asked for is the x coordinates, not just the coordinates, so we don't need to do anything more than that. Okay, so BII, the equation of the tangent to the curve of y equals f of x at x equals 1. Okay, so what that's asking for is pretty much, alright, we need our tangent line pretty much, so it's going to be, a tangent line is going to be an equation of this just touching our curve. So all we need is the instantaneous gradient and that specific point, and the equation y equals mx plus c. Okay, so we already worked out what the gradient is at x equals 1, so we know our m is negative 12a for our mx plus c. And now we need pretty much the y value, because we've got the x coordinate, but we don't know what the y value is. So if I put x equals 1 in here, so in other words f of 1, I'm going to have a times by 4 minus 1 squared, all squared, and that's going to be, what's that, 3 squared, so 9a, so we'll have 9a. So now we've got a coordinate, this is an x and a y coordinate, and we can put this into here to find our c. So we have y equals currently minus 12a, x plus c. So now I can substitute this information into here to find pretty much our c value. So I'm going to have 9a equals minus 12a times by 1 plus c. So in other words, I'm going to have 9a plus 12a equals c. So I'm going to have, what is that? I think that's 21. So 21a equals c. So the equation of my tangent is going to be, let's rub this stuff out so I have a bit of room. Y equals minus 12ax plus 21a, and that's it. Okay, and that's it for today's video. So this was a part 2 to the chain rule stuff, so a lot of it was question heavy. A lot of our examples we did in the previous one, so if you haven't checked out that video, give that a check, pretty much a look. It's pretty much all these questions up here that we went through together. But yeah, if you had any questions about this one, leave something in the comments and I'll try my best to answer them. Thank you so much.